Hi Anthony, sorry finally I've got time to sit down and do a video for you for the circuit question. So what I'm going to start with is the example from your textbook and just explain how they're arriving at these equations. And I think once you understand that, it'll be really easy to apply that to the other question that you're being asked to do. So the current law and the voltage law are the ways that we're developing both of these equations. We're going to start with the current law. And basically what they're doing there is they're looking at each individual node and they're making an equation based on what's coming in and going out at that junction point. So in the case of B, for instance, we've got this current I that's going to travel up and around the corner and up to B. When it gets to B, it splits off. It goes off in two directions. It goes off this way and it goes off this way. And what we know from Kirchhoff's law is that the amount of current coming in has to equal the amount going out. And so I1 and I4 have to be equal to I. So if I put all the i's on one side, I end up with I minus I1 minus I4 equals 0. And that's how I get this equation right here. So at node C, if we try that again, let's do this one in a different color just so that we can keep track of it. So here's node C. So we have to look at what's coming in to node C. And what's coming in is I1, right? It's on its way here around the corner. It's coming up and it arrives at C. When it gets to point C, it splits off again in two directions. It goes this way and it goes this way. Now this way is I2 and this way is I3. So again, that tells us for node C that I1 coming in has to be equal to I2 going out plus I3 going out. And if you move all those guys over to the other side again, you end up with this equation, which is exactly the same as this equation. So for node D, the same idea. Let's use a different color again. Here's node D. What we have coming into node D is I2, and then it's splitting, isn't it? It's going this way and it's going this way. So I2 starts out coming in and it gets split up into two things. It gets split up into minus I5 because it's going the other direction there. See how it's the arrow is going this way instead of the other way? So I have to do a negative I5 plus the I, which is the one coming around the corner here. So if I put everything all on one side, I end up with I minus I5 minus I2 equal to 0, and so on, okay? And that matches up with this equation down here. So that's how we're finding the current law equations. Now for the voltage law, it's a little bit different because every time we travel across one of these resistors, we're going to multiply the I value by that resistor. So let's erase what we've got on here because it's a little bit messy. And now we're going to look at it from a voltage point of view rather than a current point of view. Oh no, it won't let me erase. Okay, it won't let me erase. So this is a little bit messy. I'm not sure what we can do here. Okay, I think I've solved the problem. So I took another picture of the same circuit so that we can talk about the voltage this time. Okay, unfortunately I don't have the equations showing, but we'll work from there. Okay, so the idea behind the voltage law is that the sum of the voltages around a closed loop always have to equal 0. So when we look at a closed loop, the first circuit that they look at in the example is A, B, E, D, A. In other words, from A to B to D, sorry, to E to D, and then back to A again. That's a closed loop. So we know that the voltage has to equal 0 all the way around, okay? And so as we're looking at the voltage, the first thing we see is that the voltage coming around this way is I4, and it's going to go across a 1 ohm resistor. So we do 1 times I4, and we get equals I4. And then as we move through this hub at E, we're now going to travel across this resistor, this 2 ohm resistor, with voltage I5. And so we're going to go plus 2I5. And then we're going to come back to here with nothing else happening, and we know that the whole voltage in the circuit is the 10 volts from here. So that's where the first voltage law equation comes from. The second voltage law equation comes from the closed circuit B, C, E, C. So B to C to E and back to B again. So when we're looking at that circuit, we've got voltage I1 going across a 2 ohm resistor. And so that's going to give us 2I1 plus we've got voltage I3 going across a 2 ohm resistor. So that's going to be 2I3. And then it comes back to I4 going across a 1 ohm resistor, but it's going the opposite direction, so we're going to have to make it negative, so it's minus 1 I4 has to equal 0, because all the way around our circuit has to be equal to 0. And so that's our second equation for the voltage law. For the third equation, we're looking at this closed path, C to D to E to C. So starting at C, we've got I1 that's still coming up here. Sorry, no, not I1. Forget about I1. He went down there. We've got I2, there he is, okay, coming across here. So I2 times 1 ohm, which is I2. And then I5 goes across the 2 ohm resistor, but the wrong direction. So that's going to be minus 2I5. So we put minus 2I5. And then I3 is going the wrong direction. So it's going to be 2 times I3, which is minus 2I3 coming back up to C. So that's the third of our voltage law equations, and then you put them into your matrix and you solve. So that's a long explanation of the example. And now what I'm going to do is look at question 20 with you and set up the similar thing for the question that you need to do. I think what I'll do is send you a second video, because sometimes when these are too long, YouTube won't accept them. So I'll send this across for you to look at, and then I'll send you a new one on question 20.